Hi guys, uh, I will try to explain to you the page replacement portion of this node, which I believe is a little difficult to understand. Otherwise, the entire node is self-explanatory. Now, how this page replacement algorithms work, to understand that portion, let me go back to the beginning of this material. Uh, if you have gone through the note, you might have observed that a page is basically a fixed size partitioning scheme of the main memory as well as secondary memory. Now, how this uh, page partitioning is done? In paging, secondary memory and main memory both are divided into equal fixed size partitions. Okay, now when you come to the main memory, these partitions are called frames, and when you come to the secondary memory, these partitions are called pages. Now, what are these pages? These pages are basically virtualization of processes. Each process is divided into parts where size of each part is same as page size. Now, why this partitioning is necessary? To understand that, let me draw two diagrams. First, say this is your RAM, and this block, this block is your secondary memory. Fine. If you can remember the part 1 of this tutorial, you can figure out that size of RAM is much smaller than size of the secondary memory. So essentially what will happen for some of the processes which you need to load into the RAM will have much larger size than the size of the RAM. So essentially in one go you cannot load the entire process. So what is the solution? To find the solution, let me again go back to paging. Just come to this example. Here what is being done? A process is divided into some subparts, and part by part it is loaded into the main memory from secondary memory. And the subparts are the subparts are not real. These are virtual subdivisions. These virtual subdivisions are stored into your secondary memory. Now, each and every subpart is loaded into the frames of main memory as pages. Now, come to this page replacement algorithm portion. So why you need this page replacement algorithms? This is because of page fault. Now, what is this page fault? Just read the definition once again and try to realize it. When a page referenced by the CPU is not found in the main memory, it is called as a page fault. How this happens? As the size of the RAM is much smaller than secondary memory, So entire process sometimes cannot be loaded into the RAM. If you explicitly try to explain this term, then what happens? A process which is divided into pages, to run the process, all the pages need to be loaded into the RAM. But sometimes the size of all the pages together will exceed the size of the RAM. So essentially, you cannot load all the pages in one go into the RAM. The solution is load the pages one by one. So where is the page fault? To find the occurrence of page fault, let we divide our RAM into frames. These are actually your frames, and divide the secondary memory into some virtual small blocks called pages. So these are your frames, and these are your pages. Essentially, the size of a frame will be equal to the size of a page. Now, when a page fault will occur, say you have a page P1 in frame 1 of the RAM, page P2 in frame 2 of RAM. It is a little difficult to write with the mouse. Please cooperate. Page P3 in frame 3 of the RAM, page P4 in frame 4 of the RAM, page P5 on frame 5 of the RAM. So now you can see that the RAM is basically full. Now let me make one assumption. Say these 3 pages belong to a process PA, and these 2 pages belong to another process called PB. Now say this process PA has another page 6, which is now residing into the secondary memory. Now once the execution of these 3 pages, contents of these 3 pages are complete, you need to load this page 6 into your RAM. Now as the RAM is full, there is no way to load this page 6 other than removing an existing page from the RAM. So essentially a page fault occurs here. Let me come back to the definition of page fault. When a page referenced by the CPU is not found in the main memory, it is called as a page fault. Again, go back to our diagram. If here is our CPU, now after the task is being done on these 3 pages, CPU requires this page P6, which is not found into the RAM. So what happens? It is a page fault. A page fault occurs here. So what is the way out to get rid of this page fault? Solution is, when a page fault occurs, the required page has to be fetched from the secondary memory into the main memory. So you need some replacement algorithm here. You need to replace some existing pages from the RAM. So Whenever we say replacement, we essentially need some algorithm. Some common proposed algorithms are FIFO, which you know, first in, first out, then LRU, least recently used, then optimal page replacement algorithm. We will study them one by one. To understand the working behavior of these algorithms, let me fabricate one demo problem. Look into the demo problem. Demo problem is something like a system uses 3 page frames for storing process pages in the main memory. So what this line says? This line says, this example, we have 5 frames into our RAM, or in other words, we have divided our RAM into 5 pages. And in this example, what happens? In your RAM, say this is your RAM. In your RAM, you have 3 frames, and then again go back to the problem. Next assumption is that all the page frames are initially empty. It means that in your RAM, all the 3 frames are initially empty. That means if in this present condition CPU requires some page, a page fault will essentially occur because the item is not available into the RAM. Again, go back to the problem. The problem asks what is the total number of page faults that will occur while processing the page reference string. This is your page reference string given below using different page replacement policy. So to demonstrate the page replacement policy using different algorithms, let me copy this reference string and paste it into our sample diagram. So these are your page reference numbers. So these are now, for the time being, is residing into your secondary memory, and this is your RAM, and these are your frames. These are what? These are frames. This is frame 0, this is frame 1, and this is frame 2. Let me add one column in this table and resize the table and write it down, frame numbers. Frame 0, frame 1,